This lesson is Properties from Algebra, section 2-2 in your textbook. The essential question is, what are the algebraic properties of equality that will be used to write proofs and solve problems? The first of these properties of equality is the addition property. And this property simply states if A equals B and C equals D, then A plus C equals B plus D. The next is the subtraction property. And this simply states that if A equals B and C equals D, then A minus C equals B minus D. Next, we have the multiplication property. And this says if A equals B, then CA equals CB. Now next, we have the division property. And this property simply says that if A equals B and C is not equal to 0, then A over C is equal to B over C. We have four more properties of equality, and the first of these additional four is the substitution property. And this property simply says if A equals B, then either A or B may be substituted for the other in any equation or inequality. The next is the reflexive property. Now this is one that's somewhat obvious to most people and as a result is somewhat difficult to understand. And it simply states that A is equal to A. I like to think of the analogy to this as being when you look in the mirror, what do you see? You see yourself, okay? It seems rather obvious, but it is a required property in a lot of proofs. And the next is the symmetric property. And this property states that if A equals B, then B equals A. So we have symmetry. A equals B, B equals A. And finally, the last of the properties of equality is the transitive property. And this property says if A equals B and B equals C, then A is equal to C. Now, sometimes people get confused between this property and the substitution property, but if you look at it closely, there is a slight difference in the two. Now, one thing to know is that these last three properties of equality, the reflexive property, the symmetric property, and the transitive property, lead directly to properties of congruence when we're talking geometric figures. In other words, there is a reflexive property, a symmetric property, and a transitive property when it comes to congruence. These are properties of congruence. So these three properties are both properties of equality in terms of algebraic numbers, as well as being properties of congruence in terms of geometric figures such as lines, angles, etc. Now, another thing to note about these properties is that much like postulates, none of these properties have to be proved. All of them can be used as reasons in a proof. Now, this leads us to how do we go about writing a proof? Now, most of the proofs we use in class are going to be two-column proofs, okay? And there are certain things that are required when you're writing a two-column proof. Now, the first of these is a given statement and a proof. So in the upper left-hand corner, one must first write given and say, what are the facts that you are given, okay? And then directly below that, you must write prove, and you must list or explain what you are being asked to prove. So let's look at a specific example. So as an example, let's look at this given statement. Line segment RT and line segment PQ intersecting at S so that RS is equal to PS and ST is equal to SQ. Notice, we have a diagram as well. So this is another thing that is required when we're doing a two-column proof. You have a given statement, and then you have a diagram showing what the given statement says. And finally, what are we asked to prove? In this case, we're asked to prove that RT is equal to PQ. Now below this, we have two columns. The left column is going to be a column of statements, and then the right column is going to be corresponding reasons for each one of those statements. So let's begin. The first statement, and we always number our statements and number our reasons. So statement 1 is going to say RS is equal to PS. And ST is equal to SQ. Now, the reason, we put number 1 again so that we have the corresponding reason. Why do we know that this statement is true? It was given to us. So the reason is given. All right. Statement 2 is going to say that RS plus ST is equal to PS plus SQ. Now, what allows me to say that is the addition property of equality. And it's okay to abbreviate, just so long as you know the abbreviations are understandable. So I'm just going to say add property of equality. Okay? Now, statement 3 is that we know that RS plus ST is equal to RT. And we also know that PS plus SQ is equal to PQ. So what's the reason for step 3 here? The reason here is segment addition postulate. Now you could write the postulate number. It's sufficient to just say segment addition postulate. You could also explain it in words if you wanted to, but I just like to, since it's fairly well known as the segment addition postulate, just write it as such. All right, and then lastly, if you look at step 2 and step 3, you can see pretty clearly that RT must equal PQ, and the reason for that is substitution, or the substitution property. Okay? So here's a fairly simple proof 2-column proof, 4 steps, and in the format that I want all of your proofs to be in, okay? A given statement, what you're asked to prove, a diagram, then 2 columns, statements, and corresponding reasons with them numbered. Now I would like you to go to the classroom exercises on page 40 in your textbook and do problem number 11 and post your answers in the Dropbox.